shearing strain. Shearing strain. We have to define shearing strain. So in the diagram we have a cube and a deforming force F is applied. A deforming force F is applied on the upper face of the cube tangentially. F is the deforming force which is applied on the upper face of the cube. In this case, ABCD is the face or plane uh, which is perpendicular to the fixed or lower face BHJC. Due to application of this deforming force, due to application of the deforming force F on the upper face AEKD, the side or the arm AD will move to this position, to this dotted line position, and the arm or the side AB will move to the position A prime B prime, and the arm AD will move to the position A prime D prime. The side AB will move to the position B A prime. That means the face ABCD will be displaced to the position A prime BC B prime. Similarly, the side EK, the side EK will move to this position E prime K prime, and now we can connect E prime and H. We can connect E prime, E and E prime, and K and K prime. And similarly, we can connect H and E prime, and J and K prime. The final position of the face or plane EHJK will be E prime H J K prime. This is the final position of the plane EHJK. Due to application of the deforming force on the upper face tangentially, the plane EHJK will move to the position E prime HJK prime. Now, the angular displacement of the plane or of the face ABCD, which is perpendicular to the fixed plane BHJC, is theta. Theta. Theta is the angular displacement of the plane ABCD. Similarly, the angular displacement of the plane EHJK is theta. The face of the plane EHJK will be displaced to the position A prime A J K prime, and theta is the angular displacement. So this angle will be again theta. Small l is the length of each side of the cube. Small l is the length of each side of the cube, and this is also the length of each side of the cube. L and L because each face of the cube is a square. And x is the linear displacement. That is, x is equal to a prime, and e prime is also equal to x, and x is the linear displacement of the face ABCD due to application of tangential deforming force. In diagram, F is the deforming force which is applied tangentially on the upper face of the cube so that its shape changes. when a deforming force when a deforming force F is applied when a deforming force F is applied on the upper face AEKD AEKD of a cube of length L each side of length L each side tangentially. That means deforming force is applied tangentially on the upper face AEKD of a cube of length L each side. That means a deforming force F is applied tangentially on the upper face AEKD of the cube. Then the plane ABCD, which is perpendicular to the lower fixed plane BHJC. The plane ABCD, which is perpendicular to the lower fixed plane BHJC of the cube, BHJC of the cube will have an angular displacement theta, will have the angular displacement theta, and the sides AB, the sides AD and EK of the upper face of the cube will be displaced by a displacement x to the position will be displaced by a displacement x to the position A prime D prime and E prime K prime respectively. Hence, the shearing strain, shearing strain is defined as the ratio, or shearing strain is defined as the displacement angular displacement theta is equal to angle AB A prime or angle EH E prime of a plane or face of the cube of a plane or face ABCD or EHJK, which is perpendicular to the fixed plane, to the lower fixed plane BH, fixed plane or face BHJC of a cube. ABCD or EHJK, which is perpendicular to the lower fixed face or plane BHJC of the cube, provided a deforming force F, deforming force is applied on the upper face of the cube, upper face AEKD of the cube, tangentially of the cube, tangentially within the elastic limit. Shearing strain is defined as the angular displacement of a plane or face which is perpendicular to the lower face. In this case, due to application of this deforming force, in diagram, due to application of this deforming force, if and this deforming force is applied on this upper face AEKD, and the plane ABCD will be and ABCD is perpendicular to the lower face BHJC, to the lower fixed plane BHJC, and ABCD is the plane which is perpendicular to the lower fixed plane. BHJC is the lower fixed plane and ABCD is the perpendicular to the lower fixed plane, and ABCD will have angular displacement theta, and this angular displacement theta is the shearing strain. Therefore, shearing strain equal theta. Shearing strain equal theta. Now tan theta equal A prime divided by AB from the triangle A prime A B, or comma theta equal A prime divided by AB. Under bracket, if theta is very small, then tan theta is approximately equal to theta, or theta equal x by L, theta equal x by L. That is the shearing strain. So therefore, in this case, x is the linear displacement of the upper face or upper plane of the cube. X is the linear displacement, and F is the deforming force which is applied on this upper face tangentially. L is the distance of the upper face on which deforming force is applied tangentially from the lower fixed plane. From the lower fixed plane. Therefore, shearing strain. Therefore, shearing strain equal x by L. That is another mathematical expression of shearing strain, which is the ratio of x and L. So if we draw the diagram again, this is a cube on which a deforming force is applied tangentially. This is the cube, and the deforming force F is applied on the upper face of the cube tangentially, and name of the upper face or plane is AEKD, and the arm AD will be displaced to the position A prime D prime, and EK will be displaced to the position E prime K prime, and X is the linear displacement of this upper face. BHJC is the lower fixed plane of the cube. L is the distance of the upper plane or upper face of the cube from the fixed plane. Therefore, shearing strain is defined as the ratio. Shearing strain is defined as the ratio between the linear displacement x, linear displacement x of the upper face or plane AEKD of the cube, linear displacement of the upper face or plane of the cube on which the deforming force F is applied tangentially, and the perpendicular distance and the perpendicular distance of that upper face or plane AEKD from the lower fixed plane, perpendicular distance is L, from the lower fixed plane or face or plane BHJC of the cube. So that is the definition of another definition of shearing strain. So in the diagram, this is the upper face on which, and L is the distance of this upper face from the lower face, lower fixed face. Therefore, shearing strain is equal x by L.